Hi, this is Professor Muldrow, and I am here to show you Chapter 2, Lab number 3, which has to do with nested loops. Now, a nested loop is one loop inside of another loop, in this case, two for loops. So on this slide, you see we have an outside for loop using a loop counter letter I that goes from 1 to 5, and an inside loop with a counter named J that goes from 1 to 10. It's used to draw this figure with 50 stars. Typically, when you use nested loops to draw figures, the outside loop will reflect the number of rows. The inside loop will be for the number of columns, or the characters drawn on each row. So that's why you have 5 rows, and each row has 10 stars. So that fits. Now you can change that up. In this case, you still have your outside loop going from 1 to 5, but this time your inside loop goes from 1 to whatever the value of I is, since our condition is j less than or equal to I. So when I is 1, the first row will have 1 star drawn on it. When I is 2, the second row has 2 stars drawn on it. When I is 3, 3 stars on the third row, and so on and so on. Here in this example, same thing. Outside loop goes from 1 to 5. Inside loop goes from 1 to the value of I. But this time, we're printing the value of I. So that's why in this output, we get 1 1, 2 2s, 3 3s, 4 4s, and 5 5s. Now, this one is a little more challenging. As you can see, we have an outside loop going from 1 to 5, and we have 2 inside loops. And this first inside loop has a rather interesting condition on it. It says from j less than or equal to -1 times line plus 5. You might be thinking, where did they come up with that? Well, I'll show you. Here I have a loop formulas table. Now what you're going to do in this table, this one right here, is first we put the number of dots that are on each row. The output's down here. The first line, or first row, has 4 dots. Second row, 3 dots. Third row, 2 dots. Then 1 dot on the fourth row, and no dots on the last row. You want to come up with a formula that will give you each of these numbers to be able to use as the loop condition. Well, the formula must contain the line number. In this case, when there's 4 dots, the line number is 1, so I'll put a 1 here. Now, another thing to keep in mind is this. If the number of things you're drawing is decreasing as your line goes down, you must multiply the line number by a negative number. If the number of objects is increasing, you multiply the line number by a positive number. In this case, the dots are decreasing, so it's a negative number. Negative what? The dots are decreasing on each line by 1. We go from 4 to 3, 2, and 1, and 0. So that means since they're decreasing by 1, we're going to multiply the line number by a -1. In this case, 4 is supposed to equal -1 times 1. Well, -1 times 1 is -1. We need to turn a -1 into a 5. You do that by adding 4. No, I'm sorry, you need to turn it into a 4. So you add 5. Let me get that right. -1 times 1 is -1. If you add 5 to that, that gives you a positive 4. So there's the math equation using our rules, if you will, to get the right number. Now then, on line 2, we have 3 dots. The line number is 2. The dots are decreasing by 1, so we multiply 2 by -1. And that gives us a -2. But we don't want it to be a -2, we want it to be a 3. Once again, we add 5. And this then gives us our general formula. It's -1 times the line number, I'll use line, plus 5. Okay, Now, as far as the number of numbers on each line, that one's easier. Line 1, 1 number. Line 2 has 2 numbers. 3, 4 on line 4, 5 on line 5. So the number of numbers on each line is actually the line number. So that's why we just use line there. So as you can see, this formula turns into the formula in the loop condition for the first inside loop. And then this formula turns into the loop condition for the second inside loop. This is how you figure out loop conditions when you're trying to draw figures with nested loops. Okay. So now what I'll do is I'll go down to our actual lab. There are other examples of how you would come up with formulas. For example, here suppose you want the loop to print these numbers, 2, 7, 12, 17, and 22. Okay, the first number, line 1, is going to print a 2. Well, let's see, we have 1, 2, 3, 4, 5 numbers. All right? So to get a 2, we take the number, and the numbers are increasing by 5, 2 to 7, 7 to 12. So you take 5 times the line number, in this case the variable count, that's 5 times 1. But that gives you 5, you want a 2, so you have to subtract 3. Similarly, if you want a 7, that's on line 2. So 5 times 2, the line number, is a 10. But 10's too big, we want 7. 10 minus 3 is 7. And so therefore, the formula to get this sequence of numbers in a loop is this one right here. 5 times count, or line, minus 3. Now then, let's go down to our main exercise, this one. We want to draw this. As you can see, you have lines with dots. So there are 4 dots on the first line, 3 dots on the second line, 2 on the third, 1 on the fourth, 0 on the last. This looks very familiar. Well, here's line 1. The dots are decreasing by 1, so we multiply the line number by a -1. -1 times 1 gives me a -1, but I want to get a 4, so I have to add 5. Do one more to establish the pattern. It's -1 since they're decreasing by 1 times the line number, which is 2. -1 times 2 gives me a -2, but now you add 5 to get 3. So once again, the formula is -1 times the line plus 5. In this case, we're just drawing the dots. And then at the end of each line, we put the line number just once. And that's the first part of the lab. And the code for that looks like this. As you can see, here is my outside loop using line for the line counter, and it goes from 1 to 5. And then here is my inside loop that draws the dots, and there is the formula, x less than or equal to -1 times line plus 5. And when you run this program, there's your output. Here is exactly the same figure as is on the slide. Now for part 2, notice we want this drawing, which we got. $3 signs on the first line, and then a number. $2 signs and 2 numbers, $1 sign and 3 numbers, and then no dollar signs and 4 numbers. So since there are multiple symbols repeating on each line, we need an inside loop for each one that repeats. So we'll need an inside loop for the dollar signs And then we also need an inside loop for the numbers. There are 4 lines total in this figure. The code for that looks like this. So here we have our outside loop going from 1 to 4. Then we have our first inside loop that draws the dollar signs. But notice I've got a condition on it. X less than or equal to -1 times line plus 4. Here's how we get that formula. Number of dollar signs, you have 3 dollar signs on line 1, 2 on line 2, 1 on line 3, none on line 4. All right, so once again, they're decreasing by 1. The dollar signs are decreasing by 1. So we take -1 times the line number, which is 1. That gives me -1, but I want a 3. Must add 4. On line number 2, there are 2 dollar signs. So we take -1, the amount of the decrease, times the line number, which is 2. -1 times 2 gives me a -2, but I want a positive 2. So I must add 4 to get that. And so the formula is -1 times the line number plus 4. For the numbers on each line, again, simple. First line, 1 number. Second line, 2 numbers. Third line, 3. Fourth line, 4 numbers. So the number of numbers is the line number. That's just line. Pardon me, that's just line. And there you go. You'll notice you have on your second inside loop, y less than or equal to line. On your first inside loop, you have -1 times line plus 4. This is how you use nested loops to draw figures. The tricky part, of course, is figuring out the correct loop conditions. But as you can see, if you know the right formulas, it can be done. If you have any questions, please send me an email at kmuldrow@lbcc.edu.